I had rather be Mercury, the smallest among 7 planets revolving around the Sun, than the first among 5 moons revolving round Saturn.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Hey, Johan.
Johann Wolfgang von Goethe.
I wish I had a middle name that was Wolfgang.
Yeah, Wolfgang's a strong middle name.
Solid, isn't it?
I really do like it.
So, Matt, how are you?
I'm good, Jamie. I've got my car through the MOT.
Tick.
I've had the bandage removed from my hand.
Tick. You're in a better place.
Yeah, I've written a podcast.
Both you and your car are basically physically better off.
Yes. Super exciting today. In lieu of an interview, that we're going to have a Mercury Special.
OMG. I love Mercury.
I love it.
It's my favourite drink. Just kidding.
It's my favourite metal that's a liquid at room temperature.
Is it what the T1000 was made of?
No, I don't think it was, Jamie. No, a mercury-like metal.
Okay.
Anyway, Jamie, before we get on to talking about the Merkers, let's have a quick rundown of what happened in the old space news this week.
Commercial crew program news. Big
un.
So NASA and SpaceX, Matt, completed the launch escape demonstration of Crew Dragon on Sunday.
They certainly did. Did you watch it?
I haven't seen it yet. Is it good?
Are you joking?
No, I'm not. I've been very busy.
I tell you what, the explosion of the Falcon 9 rocket that was very much brushed over in the commentary is the best bit. It's a bit like because it's because the landings have become boring now, but like blowing them up in mid-flight is pretty exciting stuff.
Well, I need to get onto YouTube at once.
Very exciting, but it looked pretty picture perfect. Do you want to hear what Jim Bridenstine said?
Hit me.
We are thrilled with the progress NASA's Commercial Crew program is making and look forward to the next milestone for Crew Dragon.
Okay, you want to hear Elon Musk's comment?
Yeah, go on then.
Hi, Bru. As far as we can tell thus far, it's a picture perfect mission. It went as well as one can possibly expect.
Yeah.
This is a reflection of the dedication and hard work of the SpaceX and NASA teams to achieve this goal. Obviously, I'm super fired up, bro. This is great. We're never, ever going to interview him, are we?
No. Well, this is the great thing. Talking of that, I think that sometimes a lot of the space journalists let Elon Musk a little bit off the hook because they do want to interview him. I'm not saying any.
We don't roll like that.
We don't roll
do
like
we?
that. We're safely.
Baby.
We're safely snuggled here in Grand Britannia.
We're too independent.
It's just a couple of rogues.
Yeah, we say what we want. Is that basically what we're saying? Because we will never get an interview with Elon.
Shut it, Jamie.
that we're just too rogue.
Maybe one day Elon will be begging to come on the show. Who knows?
Well, I think that's exactly what's going to happen. Yeah.
So, Jamie, talking of the UK. There is a UK mission to save the planet.
Oh, it's about time.
I think it's very intriguing. Just the moniker of this particular mission is called Truths.
Oh.
Which is short for the Traceable Radiometry Underpinning Terrestrial and Helio Studies.
I like that one. I'm keeping that.
But it's clever, isn't it? Truths, because it's all about climate change and stuff like that, and to be honest, this mission is actually could be very important because it would really tighten up all those Earth observation models that give us the information and finally put the nail in the coffin of all
of the naysayers
of global climate change. Anyway, reported on the BBC after the approval for the development by ESA of a £27.7 million budget, this is targeting for launch in 2026 at a total cost of about 260 million quid. So it's the UK have proposed this mission, and it's a kind of standards laboratory in space. So it's to get a kind of international system, SI, measurement traceable space-based climate calibration observing system. So in other words,
I like it.
A satellite that's so accurate, all the other satellites can use the data from this one to calibrate their own data.
That's clever.
Yeah, including some of the stuff that's in the archive as well. So this can be used for information that's been collected for decades now. Meeting at Harwell in Oxfordshire, scientists and engineers from Britain, Switzerland, Greece and the Czech Republic and Romania all were there to discuss how they're going to get this cryogenic radiometer and a hyperspectral camera into space that's detailed enough that it can make a map of the sunlight being reflected off Earth's deserts, snowfields, forests and oceans.
Beautiful.
If it can become this extreme detailed and quality instrument, it will become this benchmark instrument. It will help redefine the accuracy of climate models. Do you want to hear what Nigel Fox of the National Physical Laboratory said?
Where's he from?
He's the UK's keeper of standards, I suppose, for space.
Oh, let's do it.
As it goes. By doing that, we'll be able to detect subtle changes much earlier than we can with our current observing system. This will allow us to constrain and test the climate forecast models, so we'll know earlier whether the predicted temperatures that the models are giving us are consistent or not with the observations.
Wow, okay.
So there you go. That was Nigel Fox that I secretly, covertly recorded in his office. But Jamie, will this all be too late if it's only launching in 2026? Will Greta Thunberg be happy?
I'm hoping not, Matt. I'm just hoping not. I'm keeping my fingers and toes crossed.
Well, basically, there's yet another answer for someone if they say we shouldn't be doing space science. We shouldn't be thinking about space when there's all these problems on Earth. The problems on Earth, the solutions are very much in space.
Absolutely. Yes, we've been through this, people.
A story that you'll really like, Jamie, is some cookie news.
Oh, finally.
Yeah, some cookies in space. I'd not heard about this at all. So 2 weeks ago, a Dragon capsule, not a Crew Dragon capsule, but a normal cargo Dragon capsule, splashed down in the ocean. And on board were a bunch of space cookies that have been baked on the ISS by Luca Parmitano.
Space cookies sounds very Dutch.
Oh, do. Yeah, it would have been better if it had been one of the Dutch ESA astronauts, yes.
Yeah.
Indeed. A special zero-G oven has been sent into space about a month before Luca Parmitano actually baked them. So a zero-G kitchen is a company founded by a couple called Ian and Jordana Fichtenbaum, a company in New York. And their passion is to get a kitchen in space so that astronauts can have decent grub on their way to the moon and Mars. You know, because they're not used to having these dehydrated rubbish, but why not bake your own biscuits on the International Space Station in a nice little kitchen?
Totally.
So, yes, Ian is a Canadian space businessman who loves Montreal bagels. And his wife is book-loving Jordana, who's a social media expert for hotels and restaurants. You mix them up in a Kenwood chef, and what do you get? You get a business that can build space kitchens while leveraging marketing opportunities for foodie businesses. What do you think?
Well, that is perfect.
So helping them with the endeavour is the awesome company NanoRacks, and they help build the oven, Luigi Lab, using their plug-and-play interface for the ISS. Doubletree by Hilton. Have you ever stopped in a Doubletree?
I think I have, yeah.
They supplied the cookie dough. Parmitano cooked it. But what's very interesting is the first cookie he cooked in the oven was insanely undercooked.
Perfect. That's what everyone loves with cookie dough.
Well, the last one he baked for over 2 hours to get it just looking just right. But they've remained in the packets, so that even though they cooked them up on the ISS, they weren't allowed to eat them.
Oh man, not even one. Yeah. That is cruel.
That is cruel, isn't it?
That is really cruel.
There's pictures of Coke looking very kind of, I want to open that packet and eat it, but no, they had to put them on the returning cargo Dragon because they've got to check whether they're actually edible and what's going on.
Imagine smelling cookies baking, come hot out the oven.
Oh my God!
You're missing home.
Yeah, that's
got a glass of milk there.
Oh no!
Jeez,
That's quite exciting, isn't it? But it's also very interesting to what on earth it could be about 0G that makes cooking cookies take so long.
Yeah, I don't understand that. I mean, I'm assuming it has something to do with temperature, that they can't go over a certain temperature.
The temperature's the normal temperature of a cooking oven. No, there's something. It's right. Something to do with the gravity, but who knows?
That's bizarre.
So it'd be interesting to see when they start testing them and papers made about the science behind all that.
We can't wait to read that report.
Yeah, and you know, it in all seriousness, it has some implications for people living on, say, Lop-G, the lunar gateway, or people travelling to Mars on the Starship.
If we're going to start building, future habitats on these places, we need to work these things out.
Definitely need a kitchen. I mean, it's pathetic, isn't it, that they haven't even baked a biscuit in space, although we have now.
Have you ever bought one of those freeze-dried ice cream bars that is in every
space-related
shop?
Yes, I have. Yeah.
Not. How was it?
It was okay.
Bit powdery.
I would think that after a 6-month journey on the way to Mars, the novelty would have worn off.
I'm sure. Yeah.
Here's a really interesting story this week. Was this impact crater, the Yarrabubba, in Western Australia, and there's
yes, mate.
It turns out it's the oldest known impact crater on Earth in a granite greenstone area called Yilgarn Craton, and it was only really found in the early 2000s, revealed by aeromagnetic images. This crater is about, I don't know, almost 40 miles across. So it would have completely taken out London right the way out to the M25. So this is a big old crater. What's happened is that a paper in Nature, precise radiometric age establishes Yarrabubba, Western Australia, as Earth's oldest recognised meteorite impact structure. And that was written by a team led by Timmons Eriksson of Curtin University of Western Australia. And they analysed these little crystals, these shock crystals, neoblasts, made of zircon and monazite, using this uranium-lead dating technique. And they've pinned down the exact age of the impact to 2.229 billion years ago.
Wait, dating technique?
Mm-hmm. Yes, not your type of dating technique.
You mean Burger King?
Seating your potential partner with a Burger King. Nothing wrong with that, Jamie.
Yeah, there's nothing
other
wrong
fast food chains available.
They are available.
What's intriguing about all that is it places the impact at the end of the snowball Earth era. Or I know that you prefer to call that the Huronian glaciation. But yes, a lot.
Well, please call it by its right term.
Snowball Earth. So maybe this impact actually caused the end of Snowball Earth. Timmons Eriksson of Curtin University said,
"The age of the Yarrabubba impact matches the demise of a series of ancient glaciations. After the impact, glacial deposits are absent in the rock record for about 400 million years, mate. The twist of fate suggests the large meteorite impact may have influenced global climate. Numerical modelling further supports the connection between the effects of large impacts into ice and global climate change, Cobber. Calculations indicated that an impact into an ice-covered continent could have sent 500 billion tonnes of water vapour, an important greenhouse gas, into the atmosphere. This finding raises the question of whether this impact may have tipped the scales enough to end glacial conditions, mate."
There you go, Jamie. That, if anything, a timely reminder that global climate not only has long-term and medium-term trends, but could be switched on and off with catastrophic asteroid strikes.
Take note.
Yeah, well, so we're not just faced with anthropomorphic global climate change. We're also faced with the threat of not really paying enough attention to asteroid strikes.
Yes.
Yes.
It is a
Wake
scary
up,
thought.
wake up, sheeple.
Bloody sheeple.
We got an answer to one of our questions last week as well from Alex Lee.
Oh, yeah.
An avid listener. I love Alex.
Alex Lee.
Yeah, great. He says the Turtles nickname from the new class of Artemis astronauts comes from the fact that nicknames generally selected by the members of the preceding class and are very often poke fun at some characteristic that is common to the new trainees. In the case of the Turtles, that was Hurricane Harvey, which flooded major portions of Houston within a week of 14 astronaut candidates, the ASCANs, reporting for their first day on the job. So it's something to do with perhaps Hurricane Harvey and, yes, them being turtles because they had to swim there.
Well, there we go. Cheers, Alex.
Yeah, although Paul Fjeld, another genius listener, and I absolutely love Paul Fjeld, he says he wonders if it's to do with the Interstellar Association of Turtles Outer Shell Division. It's where when you're asked, "Are you a turtle?" you have to say, "You bet your Swiss ass I am." Remember that one? Because we actually talked about that on a previous podcast.
I think we did. Yeah.
And he says that if we ever get a chance to interview any of those 12 astronauts, we should ask the question on
we've got
air.
to do that.
So we will definitely do that. So Jamie, do you want to?
Are you a turtle? Okay.
Are you a turtle? You bet your sweet ass I am.
Bet your sweet ass I am.
So there we go. That's what needs to happen. Do you want to hear about...
thank you, Paul and Alex.
Yeah, do you want to hear about Mercury? Do you want to have a quick
finally
bash about Mercury?
Yeah, I do.
Well, let's see where it got its name from first. So, the crazy thing about Mercury, 3,500 years ago, an Assyrian astronomer would have been marking into clay, putting those little cuneiform marks into a tablet of clay.
Oh, yeah.
And those marks were the observations of this unusual star that they were calling the jumping planet.
Oh.
And just think how weird it must have seemed, because they would have seen the stars as this kind of canvas of painted stars unmoving on the canvas, the whole canvas moving overhead. But this one star, Mercury, would have been moving quite fast around on the canvas, as well as the other planets, but Mercury moving faster than any of the others. And so, yeah, it would have been odd. So they obviously, the Assyrians and the Babylonians were obsessed with the stars and wrote very, very detailed observations of the stars, which is pretty good for us because there's loads of information from that era.
For sure.
And this is ages ago as well. And so, yes, the Babylonians were similarly obsessed, and they called Mercury Nabu, which is the god of literacy.
Yes.
Yes. And the Greeks, the ancient Greeks, were calling it Stilbon, or the Gleaming.
Oh, yeah, I like that.
Or Hermes, of course, which is still used today in modern Greek. While the Romans settled, of course, on the equivalent god of Hermes, Mercury, the messenger god.
Ah, yes.
And the Maya, also, like the Romans and the Assyrians, thought Mercury to be a messenger god. Except theirs was an owl who communicated with the underworld.
An owl who communicated with the underworld. That's my kind of owl, Matt.
It's like a David Lynch owl, almost.
It is. Oh, my God. Matt, did you see the What Did Jack Do?
I haven't seen it yet, so don't talk about it.
I won't. It's brilliant.
Back to Mercury, Jamie.
Yeah.
I actually, if I had to put 10 people on a list, Lynch and Mercury would both be on there.
Oh, definitely.
Over in China, they'd come up with, this is a beautiful one, the Hour Star.
Love that. Hour Star. Okay.
That's nice, isn't it? The Hour Star. But in the Hindu god, Buddha Graha, who presides over the day Wednesday, which is bizarre because the Germanic...
Happy Hump Day.
as did the Germanic god Odin, who is associated with Wednesday as well, is also associated with Mercury as well. So there's some kind of weird Wednesday connection between Hindu and the sort of Germanic traditions.
Really is.
That's a bit weird, isn't it? So
kind of strange.
Here's some really cool facts. So Claudius Ptolemy, round about the time of Jesus.
Yeah.
Legendary genius. Not Jesus, but Claudius Ptolemy.
Jesus or Claudius. Because
I guess Jesus comes down as a good philosopher if he existed.
Turn water into wine.
Yeah, well, that is quite a good trick.
Pretty good.
I can turn wine into water, sort of.
Can you?
Yeah. Well, it's more but would realise that maybe Claudius Ptolemy realised that Mercury should pass in front of the sun. So he kind of predicted that there should be transits, but realised that they're probably quite a rare event and hard to spot because of the size. But a really startling one, about 1,000 years later, the astronomer Abu Ishaq Ibrahim al-Zakali in the 11th century described Mercury's geocentric orbit as being oval like an egg or a pine nut, but he didn't really follow it up, which is a bit disappointing because that's a pretty substantial discovery. Then fast forward another 600 years and you've got Galileo himself being the first person to observe Mercury and write about it through a telescope.
What a player.
And but his telescope was a little bit too small to see the crescent or the phases of Mercury. But only a few years later, Pierre Gassendi in 1631 saw a transit of Mercury as predicted by Ptolemy. And of course, the timing of that particular transit, as we discussed before, was predicted by Kepler.
Big Kep.
And then 7 years later, Giovanni Zuppi discovered that the planet had orbital phases similar to Venus. So that conclusively proved that Mercury orbited the sun. Big changes there, right there.
Bank that fact.
About 100 years later, you've got John Bevis at the Royal Greenwich Observatory, and he saw an occultation of Mercury by the planet Venus. So Venus moving in front of...
It's pronounced Bevis, Matt.
You think it's Bevis, John Bevis? Oh, yes.
Well, my brother-in-law has the same surname, yeah.
Yes, May the 28th, 1737. That's a very rare thing to happen for Venus to go in front of Mercury, and that won't happen again until 2133.
How old will you be on that date, Matt?
In my 70s, something like that. I don't know. Oh, God. We'll be both a similar sort of age, i.e. dead.
Yeah, very true.
Giovanni Schiaparelli, the great Giovanni Schiaparelli, in the 1880s, actually started mapping the planet. So he was able to get his telescope focused onto Mercury and suggested that Mercury's rotational period was 88 days, the same as its orbital period, and therefore it was tidally locked, like the moon is tidally locked to Earth. All that hard-won knowledge over thousands of years, I mean, literally thousands of years of observing, we sort of get to know this kind of stuff. But then, of course, we now have the era of modern astronomy and spacecraft. So we're now going to see discovery after discovery after discovery. So the Russians and the Americans started in the 30s, actually built radar that was able to bounce off Mercury, and they started using that to map Mercury with better detail. Now, during that, this Gordon Pettengill and R. Dice, using the Arecibo Observatory in Puerto Rico, famous from Bond movies, etc., they showed conclusively that the planet's rotation period was about 59 days. And that was a massive revelation. Everyone had completely bought into the idea that Mercury was tidally locked because Schiaparelli's observations were just so good. So, what on earth was going on there? Well, it took a little bit later for Italian astronomer Giuseppe Colombo, and he noticed that 59 is roughly 2/3 of 88, the 88 days that Schiaparelli had reckoned, which would mean it was tidally locked. So, Schiaparelli's were actually good observations, but made every second orbit when the viewing was good. which is something to do with the rotation period of Mercury is almost exactly half the synodic period with respect to Earth, and that's a coincidence. Which means so when the viewing is good, you see this every other orbit. You're able to see the details on Mercury. They all look like they're in the same place. But if there was good viewing the time when it was coming round, when you couldn't see it so well, you would see actually they were shifting around. So
yes.
So yeah, Schiaparelli was wrong, and actually there's a 3-2 resonance.
Unlucky Schiappers.
But this was a hard idea to shake, that it was tidally locked, because it makes sense. It's a planet very close to the sun in the same way that the moon is tidally locked to the Earth because it's so close. But then they sent off Mariner 10, and that confirmed with absolute certainty that there is this 3-2 resonance between the spin of the planet and its orbit, which is very unusual. It's absolutely awesome. But before we get onto those space missions of actually how to actually get to Mercury, man, counterintuitively, to go into the center of the solar system is incredibly difficult. So far,
I can imagine it is.
Only 2.
It's literally rocket science.
It is genuinely rocket science. Only 2 space probes have been. And of course, on the way, we have Bepi Colombo, named after Giuseppe Colombo.
Giuseppe Colombo.
So here's the problem. So imagine, Jamie, you're a skater skating around the edge of a massive, deep bowl. Imagine like
just a skater boy.
a skate park, which is this huge concrete bowl, and you're skating.
Doing some flips, looking good.
You're skating around the edge, and you're skating at Earth speed. So you're zooming around in an orbit.
Of course I am.
And you're at Earth's orbital speed of 19 miles per second, right?
Uh-huh.
But you've got to get your speed as you go down into the bowl 30 miles per second to 30 miles per second. So you've got to, 50% faster to chase down a skater who's zipping around the inside of the bowl further down the side of the well. So that is going to mean you're going to have to change your velocity by a big amount. Now, change of velocity to a rocket scientist is called a delta V, a change of velocity, delta V, and that costs fuel, and a lot of it because of the stupid rocket equation. But worse still, as you go down the sides of this very steep bowl, of course, you're churning your potential energy at the top of the bowl into kinetic energy as you sort of skate down it, which means you're only going to whiz past this other skater that you're trying to catch up with. And so again, you have to use loads of fuel to compensate, to actually slow yourself down, because you can't grab the skater's clothing, because that would be the equivalent of aero braking through a planet's atmosphere, because the skater on this bottom row is naked. He hasn't got an atmosphere. So
could you grab his?
Well, that would be litho braking. Or something like that.
Yeah.
Maybe someone can write in with what grabbing. No. Maybe people can't write in for that.
Yeah, let's not do that.
The glory of Mariner 10, Jamie. This is such an ace mission. Having read now about this, it is genius.
It's so good that I know the date.
Go on then.
November the 3rd, 1973.
So how did it overcome all those difficulties?
Well, it became the first spacecraft ever to use a gravitational slingshot maneuver, as you know, Matt. Essentially stealing energy from old Venus, well, the orbit of Venus, rather, which was left forever going faster around the sun after February 74, as Mariner 10's velocity around the sun dropped by 10,000 miles per hour to, what do you reckon?
72,215 miles an hour?
I just don't know how you do it, Matt. It's incredible.
There we go. It's interesting, isn't it, that so Venus actually got a little bit faster and is now for always ever faster, because Mariner 10 basically gave it some of its speed to reduce its own speed.
This changed the space of this changed the shape, Matt, of the spacecraft's orbit around the sun, so that the perihelion now coincided with the orbit of Mercury.
Yeah.
Sorry, that was my chair, Matt. It wasn't me farting.
Yeah,
I'm in a very squeaky chair.
Yeah, right.
I'll try and keep still.
Yeah, so once it had caught up with Mercury, it now does 3 flypasts. And owing to the geometry of its orbit, though, its orbital period almost exactly twice Mercury. So the same side of Mercury was sunlit each time it comes round for each of its 3 flybys. So it only was able to map 40 to 45% of Mercury's surface because it never actually saw the other bit. So it took 2,800 photos, and I guess one of the sort of big surprises is that the surface was pretty much moon-like.
Okay.
But it discovered a tenuous atmosphere that's pretty much just helium. It found that there was a magnetic field and that there was a large iron-rich core. Yeah, unfortunately, the Mariner ran out of orbiting manoeuvring fuel and switched off in 1975. And presumably, it still orbits the sun to this day.
We'll find out, Matt, when we go there.
Yes, but no one actually knows. It could have fallen into the sun. It could have smashed into something else. The mission boss was actually the late Bruce Churchill Murray. And he was one-time director of JPL and the co-founder of the Planetary Society with Carl Sagan and
with our mate Carl Sagan
and Lewis Friedman. And you'll like this sentence that I found because there is the Murray Butts named after Bruce Murray on Mars, and Curiosity went across the knobs of Murray Butts on its way to Mount Sharp.
Stop it. Okay, I'm not saying anything. I'm grown. 2020 Jamie is different. I'm grown up.
Oh, that's about time, Jamie.
Yeah.
So the next spacecraft that went was Messenger. You're going to like this one.
Yes.
Do you like this acronym?
Yes.
Do you like this acronym?
Here we go.
Mercury Surface, Space Environment, Geochemistry and Ranging. Messenger.
Good.
So that was 2004, quite recently. Did a flyby of Earth. Then one of Venus, then another one of Venus, and then it went into a trajectory to reach an orbit around Mercury. So it does a couple of flybys of Mercury, 3 in fact, but with a deep space burn that lasted 15 minutes. They were able to actually...
it's a deep burn.
Deep burn. They managed to get... Messenger into orbit around Mercury, which can be no mean feat, can it?
Totally no mean feat.
So only a small portion of the orbit, because it's an elliptical orbit, in fact very elliptical, only a small portion of each orbit at the lowest altitude, which is known as perihermion, because it's near Hermes or Mercury, perihermion. And that's only at an altitude of 120 miles, so half the altitude of the International Space Station. So that's coming in pretty close. But as it comes in close, the side of the planet is super hot. So actually that heats up.
It's so hot right now.
It's so hot. And that heats the spacecraft up. So they had it elliptical so that you can go in really, really close and take some photos and then zip out and cool down again from this radiated heat at aphelion. Yes, and the probe did several years, including some extended missions, of orbiting Mercury until it crashed into Mercury's surface, leaving a crater 16 meters in diameter.
Good way to go out.
It is a good way to go out. But the Messenger did quite a lot. It discovered that there was large amounts of water present in Mercury's exosphere, which was extremely unexpected. It also proved that there was volcanic activity before, that there was a liquid iron planetary core. Evidence for it at least, and that's certainly the sort of accepted wisdom. And of course, all those beautiful maps of Mercury are very much come from the Messenger mission. But of course, now Bepi Colombo is on its way, which is a ESA and JAXA mission. And I actually saw Bepi Colombo being fueled up when I went to Kourou.
Oh, stop going on about it.
But there you go. I saw it, and on our Patreon channel, I did post a little video of the mission director going through Bepi Colombo's mission. So if you want to see that, there we go. It's up on our Patreon channel.
Check it out.
Do you want to hear some ace facts about Mercury, Jamie?
All right, let's do one each. You can start.
So on average, Mercury is the closest planet to Earth. That's still one of my favourite facts ever.
Because of the 3-2 semi-tidal lock, an observer on Mercury would only see one day every 2 Mercurian years and could walk around the planet in a permanent sunrise or sunset if they liked. Which would you choose?
I think I'd go with sunrise, because you don't see as many sunrises, do you? It's got the smallest axial tilt of any planet. In fact, it's almost non-existent.
What is it?
1/30th of a degree.
It has the most eccentric orbit of any planet, except if you still think Pluto is, which we do, don't we, Matt?
I don't. I think Pluto is a minor planet.
Remember the pine nuts? And the perihelion is only 66% the distance of aphelion. So Earth is 97%, for example.
As it's so elliptic, that varying distance between the sun just basically flexes Mercury's surface load. So the tidal bulge raised by the sun is basically 17 times stronger than the moon's on Earth.
Oh,
so
what a bulge.
Yeah, so combined with its weird spin orbit resonance, that makes the really enormous complex variations of the surface temperature.
Which, as I told you, Matt, is minus 173 C at night and 427 C in the day. I mean, your cookies are going to be
They'll definitely be burnt to that.
If that's what you're cooking them at.
Yeah, the poles, however, are always below minus 93 degrees C.
And did you know, Matt, that Venus is actually hotter?
Yes. Venus is hotter, isn't it?
Yeah,
because of its atmosphere. It doesn't lose all its lose all its heat to space. Greenhouse effect.
No.
Mercury has the second highest density after Earth in the solar system. But if you remove the gravitational compression that's caused by Earth's considerably bigger size, then actually Mercury is denser. Mercury's core occupies about 55% of its volume. Earth's, it's only 17%.
So weird.
And so therefore it's the smallest planet. So it's smaller than Ganymede and Titan, but it's actually more massive than Ganymede and Titan. In fact, it's only a little bit bigger than the moon.
That's just what I was going to say. And the moon is very similar in appearance. Wrinkle ridges, moon-like highlands. It's also got the Montes, which is the mountains, of course, plains, escarpments, and valleys.
And so all the rocky bodies in the solar system have got this kind of makeup. And if it was to be more average like those, you'd expect it to be 2.25 its current mass.
Yeah.
So there's 3 big theories here. So one theory is that Mercury used to be a large planet, and then it was hit by another smaller planet, a planetesimal, about 1/6 the mass, which stripped the crust away and the mantle and just left this planetary core behind, which is a bit like, actually, what happened to the moon, where it was stripped off from the Earth's core and mantle, but even more so. But another theory is the sun was just a lot hotter when Mercury formed and vaporized the rock of Mercury. So that Mercury had an atmosphere of rock vapor that would have been carried away by the solar wind. Or, and this is probably the most likely, that the solar nebula caused drag on the particles that Mercury was accreting from, and that meant that the lighter particles were lost and not gathered up by Mercury. And the Messenger spacecraft, the results are not favourable for the first 2 because there's higher than expected potassium and sulfur levels on the surface that wouldn't be the case if the first 2 were right. So the big job for Bepi Colombo is to clear up that little mystery.
Go on, Bepi.
And do you know how they name the features on Mercury?
Go on.
If they use a name, it has to be someone who's no longer alive. So you're not allowed to have Franklin Crater, for example, named after you. So craters are named after artists, musicians, painters, and authors. So there's things like
lovely.
Beethoven Crater, for example. Your ridges and your dorsa are named after scientists who've contributed to the study of Mercury.
I love that.
Depressions of fossae are named after works of architecture. So, yes, you might have the Guggenheim Depression or something. I don't know. I haven't actually seen what.
Or Russell Towers.
Yeah, Russell Towers Depression. The Montes, or the mountains, are named for the word hot in a variety of languages.
Wow.
Yeah, I wonder if there's the should. Plains or planitia are named after Mercury in various languages. So I guess there'll be the Hermes plain and the Buddha-Gatra plain and stuff like that, as we were hearing earlier on. And yes, escarpments are going to be named after ships of scientific expeditions. So the Beagle, I guess, is probably on there. And
Beagle's got to be there.
Yeah, it has to be, doesn't it? Because I can't think of many others. And valleys, valleys are named after abandoned cities.
Oh.
Weird, huh?
Love that. Spooky.
Mercury's surface, talking of all those different features, is an absolute jumbled up mess, much more so than Mars or the moons.
Well, Matt, the sun is about 7 times brighter on Mercury than Earth.
Yep.
That's bright.
You definitely need sunblock.
You would.
Icy regions, Jamie, they're estimated to contain up to 100 billion tons of ice, which includes the North Pole that has enough water ice to encase Washington, D.C. in a frozen block 2.5 miles deep. That's what Sean Solomon, the Messenger principal investigator, reckoned.
100 billion tons of ice?
Yeah.
Any rappers out there who want a title of their next album, there you go.
Interesting one is the fact that even though Mercury is rotating very slowly because of this almost being tidally locked, it still actually has a stable magnetic field. In fact, very stable. So it's almost certain that that's because of a molten metal core sloshing around. And that molten core is kept liquid due to this this eccentric orbit and all the tidal forces caused by it. And the upside of that is the magnetosphere that it causes can trap the solar wind, and that weathers the planet quicker. The really frightening one is that Messenger discovered that the magnetosphere has got these leaks in it. There's these magnetic tornadoes, basically the magnetic fields being twisted and flowing out into interplanetary space.
That's got to be a film soon with magnetic tornadoes, surely.
Tornadoes, yeah, I know. That's pretty cool, isn't it? And these things are massive.
Twister 2.
These are massive flux transfer events. And they form these open windows that allow the solar wind to enter and impact Mercury's surface, which of course happens on Earth, where you've got the Northern Lights and the Aurora Borealis, for example. But it happens 10 times more than on Earth, and scientists can't quite work that out. They know it should happen more because it's near the sun, but not 10 times more.
Spielberg, if you're listening, Twister 2, set in space, give me a call.
Mm-hmm. You know, Ptolemy was saying that the transit of Mercury might be rare. They're actually not that rare. They happen every 7 years or so. And the reason why it doesn't happen all the time, because you think, well, why don't we just see it each time Mercury goes round, is because Mercury's inclined by about 7 degrees to the plane that Earth orbits. And you can only see it going across the sun's disk if it's crossing the plane at the time it's between Earth and the sun, which is either May or November, and that happens every 7 years.
That is pretty sick, isn't it?
gets about 51.1 million miles away when it gets close, right?
Uh-huh.
But it could get as close as 50 million miles away in the year 28,622.
And how old will we be then?
About 80.
Are we still dead?
We're still dead, I'm afraid.
Okay. Yeah, but we're going to be frozen, aren't we? And shot into space. So maybe someone will have thawed us out by then.
Collected our drifting space bodies and thawed them out.
Yeah. Turned us into androids.
And we'll be able to see it. And we'll be able to see what will sort of just be a very tiny difference in brightness, probably.
Perfect.
Now, here's one that's really frightening. You know, I said a couple of weeks ago, or maybe a week ago, how the solar system could just fall apart.
Yeah.
Well, here we go. Simulations indicate that the orbital eccentricity of Mercury actually varies chaotically. And so some numerical simulations show that a future secular orbital resonant perihelion interaction with Jupiter may cause the eccentricity of Mercury's orbit to increase to the point where there is a 1% chance that the planet collides with Venus within the next 5 billion years.
So you're telling me there's a chance?
There is a chance that the whole of the universe just falls apart. But for me,
oh God,
for me, this is the icing on the cake, Jamie. The Mercury and Einstein. There's another person in my top 10.
Here we go.
So there was a guy called Urbain Le Verrier, and
like him already.
He was getting pretty worried that a slow rotation of the perihelion point, in other words, the point where Mercury reaches perihelion, is slowly rotating around the orbit of the sun, right? And you'd expect it to do that, but it couldn't be completely explained away by Newtonian mechanics and the perturbations of the known planets. So under Newtonian physics, a planet orbiting the sun would trace out an ellipse, just like the Mercury's doing. So it's tracing out this big ellipse, and the center of mass will be the center of focus, and the point of closest approach, the perihelion, should be fixed. Now, in a normal solar system, it's not fixed because you've got other planets that are affecting it. So you've got perturbations from the other planets, and you've actually got the fact that the sun itself bulges a little bit because it's spinning. And so that will affect this and give it what's known as a precession, where this point actually starts moving around. But Urbain Le Verrier analysed observations of the transit of Mercury from 1697 to 1848, and he showed that the actual rate of precession disagreed with that predicted by Newton's theories quite a lot, 38 arc seconds per century, which is tiny, but it's like, this is an error that you need to look into. So
Definitely.
So one of the explanations, because a few years before this was happening to Uranus, and someone said, well, Neptune, so there might be another planet that's causing this perturbation to happen. And they worked out where it would be, and Neptune was discovered. And so all the astronomers loved the whole idea that there's another planet that's perturbing another one, and you can find it. So what Urbain Le Verrier did was he suggested there might be another planet that's orbiting even closer to the sun, and he called this...
Get out.
And everyone was pretty chuffed with this idea, and so started looking for this planet, which they called Vulcan. And... of course, no planet was ever found, so it still left this bizarre error. So what on earth is going on?
That is weird, man.
So the solution comes a little bit later. Enter Albert Einstein and his general theory of relativity. So essentially what is happening is that Mercury is moving very, very fast. And of course, it's therefore... It has to be considered using Einstein's general theory of relativity, because Newton's laws will be starting to break down because of this velocity. So Einstein's formula for the perihelion shift per revolution actually gives a 42.97 arc second per century, which is pretty goddamn close. And in fact, Urban Le Verrier's measurements were actually slightly out. And when you do measure it accurately, it's almost absolutely bang on. So it's possibly one of the greatest tests and verifications for Einstein's general theory of relativity there is. And of course, it answered this incredibly strange question that came up at the turn of the century. And
get in there, Albert.
And it was things like that that made people start taking general relativity extremely seriously.
Well, they should, as
they should. So yes, just so you know, 42.98 arc seconds per century, there are 532 arc seconds per century of perturbations from the other planets. So it's still a small effect. So this Urban Le Verrier must have been making extremely accurate measurements and doing like unbelievable amounts of work to strip out all these different effects to leave this unknown number.
42.98 arc seconds per century. Isn't that the speed of the Millennium Falcon?
God, it would be really slow if it was. Man, that would be, yeah. No, it's tiny. It's tiny, but I love the fact that there's these people that sit there with tables of information trying to find little anomalies, and that's just one of the big ones. I mean,
God bless them.
God bless them. Of course, I guess they were really excited that they were going to find another planet, but then it turns out that something even more exciting is going on, that we're going to have to re-look at physics itself.
Well, talking of more exciting, would you like some observing Mercury facts? So here we go, Matt. Mercury, it's brighter than Sirius, which is already pretty bright.
Of course, if you want to observe Mercury, the annoying thing is it's near the sun.
Okay.
And trying to look at things near the sun is really annoying because, of course, you've got the sun's glare all the time. Yes. And it's never nighttime when you're looking at the sun. Funnily enough.
It's very true.
So there's only sort of brief times when Mercury can actually be observed. And of course, that's in the morning and the evening. So you can just about see it just before the sun rises. You might be lucky enough to see Mercury. And just before the sun sets, you might be lucky enough to see Mercury. But of course, you can see Mercury when there's a total solar eclipse. That's quite fun.
Just like several others. Brilliant. And like the Moon and Venus, Mercury exhibits phases as seen from Earth. It is new at inferior conjunction and full at superior conjunction.
Of course, you can actually go out and see Mercury during daylight, as long as it's clear.
Oh,
and
yes.
So if you can choose a clear day where it's got its longest elongation furthest away from the sun, you can actually do quite good observing of Mercury then, although you don't get much contrast. But it's still, quite fun to see if you can observe Mercury during the day.
Here we go. So the Hubble telescope cannot observe Mercury at all. Why do you think that is?
Do you know what?
I'll tell you.
I don't know.
It's due to safety procedures that prevent its pointing too close to the sun.
Yeah, I can see that. You imagine if you pointed Hubble and you accidentally got the sun and it burnt out all its components.
It's just not going to be good, is it? Right, Matt, give me one more stat, please.
Because the shift of 0.15 revolutions in a year make up a 7-year cycle, i.e. 0.15 times 7 is roughly 1. In the 7th year, Mercury follows almost exactly, earlier by 7 days, the sequence of phenomena it showed 7 years before. Jamie, what are you going to be doing this weekend?
Well, I am going to be filming a Melton Core metal band. See what I did there, Matt?
Yeah.
Called Slipknot. I'm going to be filming them playing some great new drums and some great new guitar pedals. And then, so I'm going to be hanging out with some metalers for a couple of days. What are you up to?
I don't know. I might go down the beach and contemplate life. I may even set my telescope up and see if I can do some daylight observation of Mercury. And if not, I'm going to listen to Freddie Mercury instead.
Well, I tell you what, Matt, if you've enjoyed this podcast and you're a first-time listener, what kind of things should you do?
I think you should head over to www.interplanetary.org.uk and just have a little look around, maybe subscribe to iTunes or Spotify, maybe leave a 5-star review. And if you're really feeling cool, go over to patreon.com/interplanetary and become a patron and help us out.
Sounds like the best thing ever. Wait, are we on Instagram as well?
We're on Instagram, Twitter.
That's where the kids are at.
Yeah, that's where the kids are at. You know, you get occasional little factoid on Instagram.
And if you have a surname, Wolfgang, then we might just send you a mug. But you've got to prove it. You've got to prove it.
If your middle name's Wolfgang, you get a Interplanetary mug.
We want to see your passport.
And a big shout out to our listeners in Norway who made the Interplanetary podcast enter the iTunes top 10 science podcast this week. Yeah.
Oh my God, we are killing it. Thank you, Norway. I'm going to Norway in April, going to Bergen, back to lovely Bergen.
Oh, lovely.
Do some songwriting camp over there. So if you're in Bergen, if you live near Bergen,
you're doing a songwriting camp.
Why don't we go
Bergen.
for a drink?
You're absolutely bound to bump into Kaya. I can't believe it.
Oh, it's got to be done.
Hiya, Kaya and Chris.
Lovely people. All right, well, have a good weekend, everybody, and I'll speak to you soon. See you soon, bye.
Bye-bye, Spotcast!